The following is a conversation about the fact that whether we do like it or not, but speculation around cryptocurrencies have mostly calmed down. And what comes to light right now is even more interesting is the technology that made it all possible. These transactional mechanisms can be applied to supply chain, to finance, to governmental programs, to so many different fields. It has been maturing slowly but steadily, this technology. But what happened a couple of weeks ago is quite extraordinary because it really came to an inflection point of mass adoption. It can handle hundreds of millions of transactions per day. It offers bank-grade security. It has 240 times faster sync time, and it requires only 10% of the disk space than it used to. I know it sounds a little bit too pompous, but that's what normally happens when technology gets to inflection point of mass adoption. In this following episode, I bring you a CTPO of the company and the lead of the open source project that made it all possible. Please listen to this. Hi, Igor. Thanks for coming to the podcast.
Yep, thanks for having me.
Yes, so let's start from the start. I'll mention later in the intro that the recent technological advancement really brought the Web3 to inflection point of mass adoption, but let's start with your story because you're one of the contributors for this to happen, and there's so much to tell. There's Gateway, there's your profile. Where would you like to start?
Yeah, maybe I'll start a little bit to talk about myself, and then I'll talk about Gateway. So I'm myself an engineer by background. I've been in tech for 15 or more years. I don't know. I stopped counting, and actually, I was in the blockchain space from 2017, full time, pretty much, and got there basically by accident because I don't know who remembers that, but pre-COVID was very difficult to find anything remote, to any kind of remote position, and I really wanted to work from home and remotely, and I kind of hated this office thingy, and I wasn't able to get anything apart from a blockchain related job. Like back then I thought it's whatever, it doesn't really matter, I want to work remotely. But then from there, I think I was super skeptical about all this technology for most of the first kind of year, but then I started to more and more educate myself on how just finances work, how things I don't know, supply chains work right now, and ERP systems and whatnot. And the more I learned how they work today, the more faith I got into blockchain solutions for a lot of them. And in the end, I went to work to the Ethereum Foundation, spent a few years there, helped to create this project called Erigon, the efficient Ethereum node, and also was participating in some more, let's say, more theoretical research on the Ethereum Foundation side. And I think in 2020, in the end of 2020, that's where the Gateway story starts. As the company, because I'm switching gears right now to the Gateway. And basically, even though the company was officially created in, I think it was April 2021, if I remember correctly, realistically, we started thinking about this from October or something of 2020. And it's kind of, back then, again, there was this huge narrative. People maybe don't remember it because now it's much better than before, but it was a huge narrative about 90% of all Ethereum nodes are in AWS, 89% of all Ethereum nodes are in AWS, about this centralization risk. And also at the same time, everybody who was building anything on a blockchain, they used pretty much a single service that was hosted on AWS to get access. Nobody ran their own nodes and whatnot, and this service, let's say, wasn't the most stable. specifically in the fall of 2020. There were huge downtimes and whatnot, and basically that steered our way that okay, infrastructure is not there in place. There is no promise of decentralization is not really fulfilled right now in the blockchain. So we wanna build something that would be an infrastructure play, basically, to make an infrastructure and make sure that this infrastructure is not on AWS, to diversify things. Ideally, that it uses like just independent data centers, and also that it's reliable and has good SLAs. So you can also kind of trust your service the same way like you're trusting the for instance AWS to host your stuff. If the same way you can trust the service to run your business.
But there have been some attempts of decentralizing this, right?
Yeah, but that I said, because I was more on the app development side for a while, and a little app and the protocol. It's a little bit like, but then I saw that our vision at the Ethereum Foundation that all people just should run their own nodes on their phones, on their laptops. It's not happening. Mostly, again, the technology is not there, and there's a lot of reasons for that, and people don't want to bother with this. But then everybody is coming to these centralized solutions, and all of them are in AWS. So like it's just okay. It's a huge risk, and also it's very difficult to build on top of them, because let's say your service might go down with them for 72 hours or something like this, which is not what you want for kind of mission critical things. Okay, the blockchain didn't fail, right? It's just this service that was providing access to it. Like if you had your own nodes, you wouldn't have this downtime. So what we wanted, that if people are going towards like this centralized services access route, the more centralized services there are, then it's kind of you kind of decentralized, but on a different level. Not everybody is running their own nodes, but like there's, let's say, like right now, like 20 or something services, relatively big, then you can jump between them. And basically that's also reduces the risk of decentralization, centralization risk, and also improves reliability because there is competition. And that's what we started with. We started with RPC, basically the access for the blockchain. We spent like around, about 2 years building that. And but we already have seen that Ethereum was going through this phase that's called the merge, when they abandoned the proof of work. That's again because it's resource hungry, like it burns a lot of electricity, and replaced it with a proof of stake consensus, which is basically, well, you can run it on your Raspberry Pi or something. It's much cheaper, much better for the planet to run as well. But this opens a new opportunity, like a staking service. Like because this business model didn't exist before. There were like mining pools that you can basically connect your machine to and hope that you get like a part of the reward. But here you can basically, like, proof of stake is where to be able to produce blocks on the blockchain, you basically need to put some money at risk. That was your risk. Like if in proof of work your risk is electricity costs, basically you spend electricity, you produce a wrong block, you anyway have to pay for electricity, but you don't get the reward, right? In proof of stake, it's purely you put your money into some deposit. If you do something wrong, then this money is gone. Or like you are penalized. Like it's not that they're completely gone, but there are some penalties in place. And so we started doing the staking also very early. In the end, as you see, like it's again, there were some podcasts before me discussing the staking at length, but it grew up in its own kind of business line. But then the RPC part, to be honest, it wasn't as successful as we wanted. Like we did a very good technical solution, but I think it was very difficult we were a bit late on the market, because again, even though we started thinking, if we were actually created a company in the end of 2020 and not like in the April of 2021, I think we would have been on the same timeline as other competitors on the RPC part, but they were a bit earlier, and they grabbed market, and then they started playing the game with prices to go them down. So when we were trying to look at the prices, we saw that we're basically getting into the negative margin territory to compete. That wasn't very very nice. And then at the same time, we thought about where we can apply our knowledge in general, because again, I'm coming from the Ethereum Foundation. We have some other people who basically came from and worked at also some clients. Like again, we have some people in the R&D team. So that's how we kind of incepted our R&D department, because we wanted to, okay, we have this knowledge in the company and we need to apply it to something that's and that's how the basically R&D was born.
So let me ask you this: far not everybody working at a certain project, company, product have achievements of that magnitude, right? Because I mean, the technology has been maturing quite significantly, and there has been a certain contribution to it. But what were the driving forces for you specifically? What motivated you to do these improvements?
Yeah, I think my goal for a while, again, after that I figured out where it can be useful, I always wanted it to just replace the legacy technology where it matters. Like again, when you see that there is a vastly superior like tech, and you are like an engineer, and you see the vastly superior tech that's not used, it's kind of like bothers you quite a bit. And it's like, before, it's the same way like when Apple was before the M series of chips, in hardware, they used to work with Intel. And again, the beginning of Intel work was very good, but then in like again maybe 5 years ago, I guess M series of chip is 4 years ago. Basically, there was this huge difference between like the phones that has top chips on the market, they were really fast, and then their laptops that's basically they were overheating, they were draining battery in hours, like in an hour or something, and they were not performant enough. And the annoying part was also like, and a lot of people with like the same background as me, they were thinking that why don't you use these ARM chips, because it was even bizarre when you do the benchmarks, like typical benchmarks, single core or web benchmarks. iPhone was like 3 times faster than the top laptop from from Apple, and then it's the same stuff here, right? So you see that they're using something, super weird, that your bank, for instance, is closed on holidays and weekends, and you cannot send money. Like let's say I get an invoice just lately, and the due date for invoice was Sunday, and I know that I have to pay it on Thursday, because on Saturday and Sunday banks are closed, so money will not be transferred, and then also bank will take at least a day to transfer this money. So not to be penalized on this invoice, I need to have like 4 days in advance know that and make a transfer, right? And but if you're using a blockchain solution, it doesn't take any time off, right? You can just transfer like money or something to somebody else like any day of the week, regardless of if it's a Christmas Eve or whatever. Like it's you can do whatever you want. And I mean, it's just one aspect, right, of the things. So that's, I think, what's and trying to think about how we can be better at adapting this would be is one good thing. And let's say the Ethereum Foundation, my idea was that the tech that was running, again, we're talking about 2018, the tech that was running the chain itself, it was built more for correctness than efficiency. And basically there was geth, and it was working very correctly. But then if you run an archival node, it takes tons of disk space, so its barriers to entry to even try this thing are like super high. Even we are like as like later as the provider of like RPC, like automatically scaling back and forth, these things are it's very difficult because it's like a lot of disk space. So what we did at Erigon and some other like stateless Ethereum research is like, okay, what we can do to make them lighter, so basically reduce the barrier to entry into this technology. And yeah, that also comes to adoption, because yeah, if you want people to adapt, you cannot put the bar too high, because then you basically limit who can use this.
Let's just keep unfolding this path. So you saw that the margins in RPC were not great, right? And you had to find another way. What was the next step? Like, how did it unfold afterwards?
Yeah, and we basically already had this thing when we were trying our best to make as much automation as possible for RPC. A lot of the code written to like for auto scaling, for failovers, for backups, for things like this, all automated. And I think we also got a little bit of a request because we had this good partnership with Gnosis DAO, and they were building the Gnosis Pay product that's live now, and they were trying to basically fork OP. Back then there wasn't a OP stack yet, but there was OP, the rollup, and they were trying to fork it and provision it, and then they asked us to help. Again, this was one of the reasons when we're trying to, okay, how we can apply our core developer knowledge, okay, forking and deploy and infrastructure knowledge together, okay, forking and deploying OP stack, or not OP stack, sorry, OP is one of these things that's that was needed. And then we also heard some other people that also asked, oh, but, and then OP stack appeared and stuff like that. And then we decided that, yeah, that's probably is a good idea, since we already have a lot of automation in place. How can we use this automation to simplify provisioning of layers 2? And yeah, we can talk about layers 2 a little bit separately, but it just, again, it's about what made sense to like pivot a little bit, but keeping the expertise, keeping what the team can do and whatnot.
Let's talk about the barrier to entry. As you mentioned, you had this year when you had doubts about the technology and how it all works and all that. And I concur, because honestly, as you remember, I was thinking to embark on the journey with you, but then I thought like, okay, maybe I want to work in health tech and that tech and make this world a little bit a better place. And I did work in this in these organizations, but I'm not sure that it was actually impactful, because it was more about earning money rather than helping people. But here I started to work with a very good team, and I thought like, oh, this is at least a great team to work with and great people, and this is very, very important to have around. And then I started to realize the value of the tech as well. But these barriers to entry that we surpassed during the year, it is there for those who want to integrate the technology, right? And people think about security, compliance, privacy, especially payment systems, as you mentioned, like Gnosis Pay. We know that it has been executed and the payments information is private, but the overall big message that blockchain sends is like, hey, this is a transparent system, you can see everything and everywhere. And this mismatch of the overall big narrative that happened and exploded some time ago and the actual implementation and the actual technical intricacies, it is there. And like, how do we cross this barrier? What do you think?
Yeah, like I think the first answer, like again, we're talking about like, if you're talking about what you want, like if you want to adapt it in real world, yes, you want privacy, at least some kind of privacy, often. Then you want like economical viability of this thing, because again, if it's perfect thing, but you have to pay like $100,000 a month for like just server cost or whatnot. And the same thing with the economic viability is about finding people who can run it. It's also might be very difficult. And yeah, the third thing is more about performance that you're getting from this, because again, if you're going like through like real world utility, real world has a lot of people that yeah, again, let's say if you look at the supermarket chain or something, they're selling a ton of stuff every day. So if you want to write them on the blockchain, it better be performant. Right, so these three things are, I think, are very important. So in terms of the privacy, the first answer, again, because blockchain to some extent was an answer to the traditional finance system when everything is private, and private to an extent that basically the public cannot even audit. It's like hidden behind closed door. Who knows what's going on there? And then you see again in 2008 or in some other places where banks just doing, or financial systems, they're doing something, and nobody can even see what they're doing. You just need to have faith in them. And the idea of the Bitcoin initially was that, okay, you don't need to have faith in anything. There is like math, everything is open, and if you want to be by yourself, a bit private, then you try to be not like anonymous, because there are two different things. One is called anonymity, it's when nobody knows what you're doing at all, and then another is called like pseudonymity. And pseudonymity means there is an entity on the blockchain that you can see everything that's going on, but you don't have a link to an actual person or whoever does it. That was the first answer, because okay, just whatever, just use pseudonymity. After that, I think the next thing for the blockchain were this like privacy mechanism, and this is where the inception of zero knowledge or ZK cryptography like application came into, because there's like very different services, and what they do again is that they try to somehow hide transactions in a certain way, and ZK technology is basically a fancy, somebody called it space math at some point. I remember that name, but it's a very fancy mathematical schemas that allows you to prove certain facts about like information without leaking the actual information at all. That means that, for instance, I can prove a fact about you, that you actually have enough balance to transfer to me to buy an apple, for instance, but I don't know how much balance and who you are like for reason. Or maybe I know that, let's say if you're renting a car, that you are like over 21, or in which age group you are, basically, you like without, so it's basically a very interesting thing, and it's very generalizable. Like you can essentially prove any computation that it was correct according to a certain set of rules without uncovering the exact information that was there. And that's another answer. There was like this privacy solution, and the third answer right now is we're talking about the layers 2, especially on ZK layers 2. ZK layers 2, they do a little bit of both. First of all, you can have, for instance, with ZK layers 2, like, and again, we can talk about like which kind of layers 2 are there, but with ZK layers 2, you can have, let's say, a blockchain that's accessible by only certain parties, and only certain parties can read it and see it, but then it still posts proofs of correctness on Ethereum. And that means that as long as you know the rules of this blockchain and as long as you have the information in the Ethereum, you made like kind of certify that nothing shady is going on in this chain without even knowing what's going on in this chain. It allows you for semi-public audits without really showing what's going on and where. And I think in the future there will be a bit more of the mixture of this, but kind of this ZK technology is what brings them all together, because it's a very, very powerful tool for things like that.
Yes, I believe that's ample of information to answer that. Let's jump to another topic that also is a frequently asked question. What about compliance? I guess going back to financial institutions, or maybe some other cross-border organizations, for them, compliance in certain tax regions or in certain countries or in certain systems of regulations is important. So let's talk a little bit about that.
Compliance is, I think, to some extent, well, if we're not talking about the token sales, right? If we removing the speculative like part of this completely, because this is a little bit of a, it depends territory. Like in some places, like let's say Switzerland, it's there is some laws around this stuff. In the rest of the Europe, it's just coming something with Mika later. But if you're talking about the blockchain technology, to some extent, it's like very good for auditors, because everything because when you audit your company, often what they're asking you is like a trail of what's happened and explanation for that. And since the blockchain is like by design, it stores everything that had happened. It stores this trail, so that's why again, to some extent, it might be even easier to comply again with the blockchain solution. I'm not talking about again tokens or anything, but like blockchain as a technology. uh, I think it might simplify some of the compliance things. And the blockchain technology as technology is like completely neutral. It's not, again, all these weird and shady things that are going on with the around the blockchain part are mostly about the tokenization part. If we putting this aside, then the rest is fairly, straightforward for compliance.
And now we are moving to a new part of our program, a quick round of applications. So we'll be, yeah, we'll be talking a little bit about real-world applications of this technology, and I will give you a couple of examples of the industries, and if you can give your perspective on how this technology can be applied to these industries, that would be great. And I would suggest that the first round is going to start with the supply chain. Yes, so let's unfold the supply chain.
For supply chains, it's already been like used in a lot of places, dependent on what's the question. There is not the application, is more about efficiency and cost to bring them down. Again, as I told before, since we're starting with the early technology that's expensive, it's correct but expensive, now we are optimizing it, so it's getting more and more viable. But otherwise, again, it's good because that's exactly what you want when multiple parties can submit, let's say for supply chain, when they received goods, and then you can represent each good like as an NFT or something like this, like a serial number with NFT, and then like just go over all the, okay, it went to this one, to this one, to this one, to this one. It's very like to different suppliers. It's matches very good. The question is about, of course, last mile as usual. How do you link the blockchain entity into with the like real life thing? Maybe with like again some barcodes or something like this is. But that's where it's applied already.
Good, thanks. And let's move to the second one, which is going to be governmental services. And that can be anything with regards to transportation systems, with regards to handling citizen data, with regards to any governmental services that offer signature-based solutions, and all of this type of thing. So let's talk a little bit about this.
For me, the biggest thing there is about figuring out the tampering things. Basically, so somebody gets and rewrites history of anything, because that's what that's the obvious blockchain implication. Because, for instance, if you're having like a medical record history or like a car registry, what you can do is you can post every time something changes there. You can post like either a cryptographic hash or like ZK proof of this onto the public blockchain, and public is very important there. And that means that every time when the person, let's say, receives this like history, they potentially can by themselves verify if this history actually matches to what was on the blockchain. And it's, again, if it uses ZK or like other cryptographic proofs or something like this, it won't be privacy leaking at all. So you can still keep all the data off chain, but you can send proofs to the blockchain to make sure that nobody deleted one user from this car, or nobody added a history of family diseases to your like medical history or something like this post factum. So that's an obvious thing. Then there's, of course, stuff like different types of crowdfundings. Again, it's not always governmental, but again, it might be also voting and stuff like this. But these are like obvious things. But I think what the most useful could be is like, again, to make sure that the data is tamper-proof. And the important part is that it's not that you're publishing the data to the blockchain, because that might be an issue with privacy, but you are publishing some kind of a cryptographically strong snapshot of data, which is like either a hash where mathematics guarantees that you cannot from it recover the actual data, but you can also always verify that it's correct.
And for more business-oriented people, do I get it right that this hash is nothing too scary? It's really how most of the passwords are being stored these days, right?
Yeah, exactly. But from this hashes, yeah, from because like cryptographic hash is something that is very, very unlikely to. Well, very unlikely means you will need all time in the universe to figure out what was the data from this hash.
Good, understood. And for the third round, I would say let's talk about accounting ledger or business-oriented data, that business-oriented systems.
Data integrity and stuff, and like for instance, the thing that I know is like for instance the company registry, the cap table of a company. Currently, it's literally often it's just an Excel spreadsheet on a lawyer's computer, backup in the cloud. But you might, I mean, and also you don't know when somebody changes something, and it's a cap table. It's a very important thing. So I think for company registrations and stuff like this is very, very important. A lot of companies don't have any kind of a ledgers, even when they have, because again, if we're talking about real world companies, they always have some kind of inventory, maybe the amount of this or that was received and stuff, and to keep in a ledger of that is an obvious solution. Again, what's important for it is for this ledger not to cost money. So like you cannot use, for instance, Ethereum mainnet for that, because if you received like, I don't know, a ton of apples in your little shop, and then you need to pay like $400 to register just this for your ledger, and then every time you sell a single apple you also need to register and pay that. It's just economy doesn't work, so the fees need to be super tiny.
And how about ticketing systems? What benefits can ticketing systems get from integration of Web3 technology into their properties?
First of all, the technology works. I mean, it's just a ledger, but also it allows, I mean, you can allow or disallow people to very easily exchange or like resell tickets or something like this, which again, right now might be a big pain, but yeah. And you can set up with smart contracts. It's very easy to do because almost everything is already there, and then you just set up the rules that, okay, maybe you can freely sell this ticket a month before the event, but 2 weeks before the event you cannot sell it anymore to anybody. So something like this. So it's just technologically much easier.
And would it affect the purchasing process in any way?
It depends on how to implement it. If it's gonna be on it probably will a bit standardize it, which is always good. And it's maybe will open kind of for third parties, but it depends. Like in this case, when I'm talking about blockchain technology, it's like as boring as the internet. Like you don't know that blockchain is behind it. For you, it's just a normal, like, I don't know, QR code on your phone or whatever.
And what about rising trend of carbon credits? Can that reap any benefit of Web3?
I mean, carbon credits are basically exchanges, and it's basically, if you think about it, it's a token that like when you buy, let's say, the equipment, you're also receiving these tokens that shows your carbon depth or your carbon. They call carbon credits because you basically, when you receive something, you get into negative amount, and then you need to put it to zero somehow. And it's just the same way how, again, any ledger or bank or exchange, it's very, like, actually technically it's very similar to any kind of exchange when you exchange tokens on the blockchain. So apart from these tokens, you cannot freely give them away, because there was this standard before called soul-bound tokens, when again the idea was that, for instance, for the driver's license or something, it's being issued by somebody else to you, and you cannot give it to anybody else. But the authority can do something with it, let's say block it or something. It's kind of the same schema when the issue. But soulbound tokens were always an idea to have an NFT, because, like, again, driver's license or passport or something with unique numbers. Here, carbon credits is much more like ERC20, just normal tokens. When they again assigned to you, and you only can pay somebody back to get rid of this debt. So it's here.
And for the last one, let's just roll back a little bit, because in the very beginning of our conversation, you did mention a little bit about financial services, but let's maybe talk a little bit more about that.
I mean, there's a lot of like stablecoin projects going on, real world assets, on chain. Again, it's more about how we can. Again, the blockchain is a little bit also about ownership, because right now, today, let's say you have to like have a bank account, somebody else has custody of like 99% of your money usually, unless you're keeping like heaps of cash somewhere in your apartment, right? And blockchain allows a bit more, how to say it, it opens the market a little bit, and adds a little bit more flexible solution. For instance, when you might want the custody of some money yourself, some you want to bank, and then you want to move. And then let's say one big thing, which is, again, it's difficult because it's, again, this area is very, very high on the compliance. So it's not about the technology, it's about compliance. But things like, for instance, I recently moved, right? And I had a very good credit score before in the previous country, and now my credit score is back to zero because I'm new in this country. And transferable credit scores is one other thing that might be very cool to have, and the blockchain can open up for that very easily.
And this concludes our quick round of applications. See you in the next episode. Thanks for that. So this is very valuable for everybody who listens to this, especially business-oriented people or those technical-oriented who want to communicate to their business-oriented people, like how to get the benefit out of the integration of new technology. But let's jump to the next very important question of scalability. What can you tell about this? Because maybe we want to have a little bit of an overview of how scalable the technology was and has become now.
Yeah, we can go back a little bit in time, and I think the fees in the blockchain were an issue as soon as the tokens of like Bitcoin or Ethereum started like at least worth something. And before that, it was basically Ethereum was always we see, like, again, the first kind of thing that's the early blockchains, they were lacking the like performance and lacking scalability, and we saw this in the project, like, again, CryptoKitties back then. But okay, CryptoKitties is active, nothing else can happen on the blockchain. And there was this idea to introduce it was called first the project Serenity, then it was called Ethereum 2.0, and basically like to introduce some kind of a sharding in the protocol. And that means that, again, like in the real world, in the large scale applications, you usually don't keep like a single database, because then you will have a lot of risk. What you keep is like pieces of data in multiple databases. And for instance, the most obvious thing is like regional split. For instance, for Europe or for a certain country, you have database instance, for another country you have another one, and that's where you can kind of split the data into, even you can store data for like billions of people, but since they're all split, you have like a lot of database, and it scales that way, and each database is independently independent from each other. So performance, again, you can work with performance somehow nicely. So to bring the same idea to the blockchain, again, it was the project from, well, I think 2019 and further. So they started implementing this. The first idea was, okay, we'll implement so-called beacon chain and then add shards to it. And this project took a lot of time. And in the end, I think everybody got so impatient about this. So instead of having the sharding path and upgrading ETH1 to ETH2, like it was, what's happened is basically there was this merge when the consensus mechanism changed to the beacon chain, and now it's proof of stake, so Ethereum works like this. But the sharding, basically, we still want performance, because this did nothing for performance at all. It just changed that now you don't mine with electricity, now you do it with the proof of stake. But performance didn't grow. But then what happened next is that, okay, but the alternative for this was this article, I think from Vitalik, I don't remember in which year, but we can probably add it to the links, because it was called like a rollup centric roadmap of Ethereum. And his idea was that instead of going into shards, means basically creating Ethereum and like splitting it into multiple layer ones, multiple pieces of layer one, what's happened is that he opened the idea that there should be like a layer on top of Ethereum, and there could be multiple of them, and you sort of achieve sharding that way. And you call it them, before it was just rollups, and rollups were basically, it's a very strict definition when basically you have a separate blockchain, but every transaction that's happened on this blockchain needs to be sent to layer one in a certain, maybe compact way, and also there should be some kind of a verifications that everything was done correctly, also sent into the layer one. Both these things needs to be true, and then you have a rollup. That's why there was a rollup centric roadmap. But then very quickly, again, and the public rollups were launching, like I think one of the first one was actually Starkware, with a very limited one, not EVM compatible, called Stark X. There were something else, some others, but and then Optimism mainnet launched, like Arbitrum launched, yada yada yada, and then everybody very quickly saw that the issue with the pricing on this, because again, if you have a layer 2 and they're efficient in communication with the layer 1, that means that maybe like, I don't know, a couple of hundred of transactions of layer 2 can be squeezed into a single transaction on the layer 1, so you get obvious 300 cheaper and 300 more like scalability factor. And then if you have multiple of them, you also multiply by that. But then they very quickly saw that sending data back to Ethereum is the most safe approach, but it's also the most expensive. So if you look at the fee prices, and there are charts and stuff, that if you look at that, the data availability, so-called fees, sending transactions to L1 are like crazy high for like I don't know how much like Optimism mainnet, for instance, is sending right now, even back then. So then there was this another iteration of L2s that was called Validium, and basically the idea is that it also sends the proofs on L1, and but it doesn't send data. It sends data availability off chain. It stores them somewhere. That means that it has a huge extra, basically cheap, because it's vastly more cheap than the rollup, because again, instead of sending this data, which is like 90% of all the fee price to L1, it just stores them somewhere, either for free-ish, just again kind of data availability committee, or maybe to another blockchain, like specific blockchains like Celestia or like something else. Again, Celestia was already after Validiums were invented, but whatever, like to something else that's cheaper with its own fees. And this is of course the solution is a bit more risky, and it's the tie between kind of Validium and L1s are a little bit looser, because you still need to have some kind of verifications or checkpoints on L1, but then you don't need to send the data. So the idea for rollups initially was also that to get yourself like a copy of this rollup, you don't need anything apart from L1. You don't need any data from off-chain. For Validiums, you need data from off-chain. So again, it's a bit like that. And then the next iteration was that blobs were introduced into Ethereum. So even rollups, they're not sending data directly on the blockchain, but they're sending it into a specific so-called blob space. And blob spaces are just some basically piece of P2P technology that's optimized to store data. So and that's where Ethereum kind of took some ideas from data availability. So it's like all coming together. But and after the idea also was that there will be just a few L2s, maybe like again 5, 10, and it's gonna be enough for everybody. Famous last words. Like okay, 640 kilobytes of RAM will also be enough for everybody. But now all the L2s, they are making these stacks, so everybody can make their own L2. And basically what we see is that there won't be like 5 L2s, but maybe there will be 5,000 L2s on Ethereum, somehow connected on between them. And also, if we look at these L2s, we also see that right now they're the perfect scenario to replace because there was this like enterprise blockchain kind of movement before, with the projects like Quorum, with the projects like Hyperledger, and stuff like this. They were basically about creating your own corporate blockchain. But again, corporate L2s I think make a bit more sense, because again, it's just the next iteration. Because again, corporate blockchains and the enterprise blockchains, they were invented in whatever 2017. Now it's 2024. Hopefully we learned a few tricks in 7 years to make things more efficient. And again, because this blockchains initially, they basically were lacking the scale for even for real world, and then they were also expensive. And so these two things, okay, they can have like privacy solutions, they were fine, they were blockchain, so all the nice parts were still there, but they were expensive and not super reliable, and also not very scalable to run. L2s though, since they were designed as scalability solutions, they're more scalable like by design, but also they're a little bit simpler. And if you're talking about the ZK L2s in particular, they're also, I think they're more secure to run than the enterprise blockchains. And again, why is that? I can it's a different story. Yeah, but also L2s, they're also going through their innovation process, even though they were introduced at some point, and especially ZK L2s being more complicated, they also started as basically less efficient version of themselves. So they're still maybe more efficient than a lot of the blockchains, but they are less efficient than they could be. And that's where things like CDK Erigon can come into play, because it's like another iteration of this process.
And let's now jump to today and talk a little bit about Erigon, because Erigon helps quite significantly with scalability of different projects, right? Of scalability of the whole technology. So how does it work?
It's basically bringing everything good that Erigon had, but to ZK L2s. And everything good means it's again more performance and takes less disk space and just again more standard, which is also important, because we saw some customers with L2 and their custom solutions, they have some issues because they used to work with Ethereum, and then let's say these nodes don't work exactly like Ethereum, so they get confused. But Erigon is, in a nutshell, is initially an Ethereum node, so CDK Erigon also works like Ethereum. But if you want to quantify it, again, comparing to the previous CDK technology, the legacy one, I think we're getting 90% less disk space usage, which is good. So it's like I don't know, instead of 6 gigabytes, it will use 600 megabytes or something like this. So then of course the sync time is much faster, and the performance of both RPC and the sequencer. And sequencer is the specific thing of the blockchain of the L2 specifically that creates the blocks and stores them and whatnot. So the sequencer performance and RPC performance is much higher. I think, like, again, we see, like, let's say at Gateway, we do see that where we could get like maybe a couple of TPS on the legacy technology transactions per second, we can get like around 100 with CDK Erigon. Again, it also has its ceiling, so it doesn't scale it doesn't scale as dramatically later, but again, it's still it's quite a lot of scale there. So basically you're getting cheaper machines, and in some of the POCs that we're doing, we're actually getting like super low prices for how can you run this if you don't need a lot of performance, basically. So it's economics are better.
And CDK Erigon was one of the major contributors to this level of scalability that we received. And can you tell a little bit about Erigon? Because you're one of the core contributors to the project, and a little bit also about maybe some technological details and a deep dive into tech and how it worked and how it enabled things to function that way.
No, but that's again, now with CDK Erigon, we just taken the technology that Erigon built and then using that. But in Erigon times, that's basically, I think initially, like the guy who started this project, his name is Alexei Akunov, and he's basically was, he thought that okay, we can do better like with just Ethereum clients. It's not very efficient, and it's basically uses back then it used the same ideas as Bitcoin used for storing the data, and where Bitcoin is much more limited and smaller blockchain, like Ethereum is much more active and much more flexible blockchains, and it just doesn't scale well this model. So again, he started to profile, figured out a few things here and there, few weirdnesses, and then again we just started like again then he got a few more people there, including myself, and we started to dig even deeper, each one in their own areas. So the big thing was, for instance, is not to store, because the data in if you look at the Ethereum yellow paper and everybody continues through that usually, and that's the naive approach, the data there is described as being a tree, like just a hexary Patricia Merkle tree, and even multiple of these trees. There's a count tree, there is a smart contract storage tree, and there is a receipts tree. There are 3 trees. Tree is not a very easy thing to store on a disk because disks are linear and trees are like branching, so you need to find a way how to store them into disk or in databases. Initially the idea, by the way, was that okay, the database is bad. We just replace a database in Geth and it's going to be working better. But then turns out, okay, the problem is not only in the database, but that it's actually naively uses the tree data instead of a flat data. But if you have a flat data, for instance, you can always generate a tree from that. And why you need a tree in the end, the Patricia Merkle tree, is not to manipulate the data through the tree, but it's to be able to verify the blockchain state. And the verification is happening through Merkleization process. When you have a tree, in the leaves of the tree you have the data itself. Then if it's hexary, then basically 16 of the children of this getting squashed together, there is a hash of them, and then each like level squishes until you have a single hash in the top. And that hash kind of represents everything you have in the tree, or it can verify everything you have in the tree. And that's how every node syncs. It just restarts on Ethereum, it gets the transaction list. And let's say when you node produces blocks, it takes transactions from transaction pool, like runs them through itself, gets the new state. Then from this state it Merkleizes it and gets a state root. Then it writes this state root as long with the list of transactions to like a block, to the block header, and then sends it over P2P. And then another node receives it, takes these transactions, runs them in the same order, gets the new state, Merkleizes it, gets the state root, and verifies if it matches or not. And then let's say if your node is doing something weird, then the majority of the nodes will reject this block because the state root will not match. So that's in a nutshell. So the tree is needed only for verification. So that's what Erigon did, is just moving we call it a commitment basically, and we move this into a separate stage when we manipulate the data when it's just flat. And flat means just very simple as you see it in the block explorer, like user like address to data, user address to data, or like wallet address to the data. And the same thing with the smart contract. If smart contract has storage 0x1 for instance, and it has 2 bytes there, the same way it's stored, like 0x1 to this, so totally flat. And then we're just building this tree only when we need to verify stuff. And then apart from that, that's already like reduced a lot of the disk space. Apart from that, we split the sync into kind of a pipe.
I'm not sure you realize this, but listening to a story like this is almost like watching somebody woodworking, for instance, right? When they take a piece of like raw wood and they start carving out, and then something elegant appears, like a Möbius strip or something like that, and it's like, oh wow, how did you do that?
Yeah, but the thing is that we thought about the disk space more, and then turns out that it's also more efficient to run things on this model, so much faster execution, much more scalability. But apart from that, after that, we split the sync process because it was very like tied together into like a pipeline. Basically, we call it stage sync, so we can look at each stage in the isolation and see what to do better. And then it's funny that like for me again, it's funny that Erigon was probably the only job when I didn't have like coding puzzles at the interview. But one of my first assignments was, okay, what if it was a hexary tree, we're making it a binary tree, what will happen for the certain like parameters. So it was a lot of algorithm. And one thing that I also wrote is that when we basically there was also an issue when you have a lot of the database inserts in general. Databases are usually based on self-balancing trees, some kind of a tree structure, because in the database you need to have an index to very quickly to jump to a certain, because you have a key, like I don't know, key Dennis, and you quickly want your, I don't know, date of birth. You need to really do it quickly and not search through the list. So it's a tree structure or something, and this tree is usually self-balancing because it's an optimal search later. But on the insert self-balancing tree is an issue because it has to, since it's self-balanced, it has to rebalance itself on the inserts. And turns out that if you randomly insert a lot of data in the tree, it gets slower and slower and slower, and because it rebalances itself, but also because the tree is stored, it's even more, I think the tree is stored is like in files, like you store them in the files in the end, the database, and database grows in size. But it usually has this kind of what you say it, like layers or segments in the data file. So it's basically, it adds like an extra, it allocates, I don't know, a little bit more space, then a little bit more space, then a little bit more space. But then when it stores this data and rebalances the tree, sometimes it needs to move data on disk, like physically. Just, okay, it was in these sectors on the disk, now you need to move it to the left a little bit. And turns out if you insert this data randomly, then there's a lot of movements on the disk, like physical movements. And physical movements on the disks are very expensive, like they're very slow. So what we know also that due to very specifics, let's say that the database that Erigon has used, MDBX or LMDB before that, they use the data structure that will not do any self-balancing if you insert things in the, like in the sorted order by keys. But transactions on Ethereum are random. You never know who did what. So what we did in the end is that when we need to insert a lot of data, we use this fancy algorithm, or fancy, that I learned in the university. It's called external merge sort, and it's basically all the data that you have, it dumps it into multiple files on disk, and it needs to dump it into multiple files because it's just too much data. It will not fit into RAM. Like you might need on Ethereum mainnet maybe like a terabyte of data to sort, or something like this. So it splits into little buffers of 300 megabytes or something, dumps them onto disk, and then does a merge sort of these files. And you might think about that, okay, but it creates extra files on disks and like does all these extra operations. It might be slower, but realistically, when we introduce this framework into Erigon, our initial sync, again, it affects initial sync, but the initial sync time, it basically reduced from, what did we have, like a week to like 4 hours or something like this, even though it was writing things on disk. So it's, yeah. And then there's a lot of other small things here and there. Yeah.
I think it's fascinating for everyone to hear that, because we came from the initial story of the beginning of the journey up until the results that it brought right now, and I know that there's still a way to go, and with a deep dive into technical intricacies of these mechanisms. So that's great. And I know that all of that has already been implemented. Going to the practical side of things, right? All of this has been implemented, and people can try it out on Presto, right? So maybe you can tell a little bit about that.
Yeah. The Presto is basically the platform that allows you to spin like a layer 2 very quickly. Like, and again, it will use like CDK Erigon and all the latest technology, or maybe some other stack if needed, but mostly CDK Erigon, and then provisions all the infrastructure there, sets it up correctly, and like adds ZK prover and whatnot, and then you can just use it already. Like, because again, we are focusing at gateway and in the R&D and just in general gateway and being good at infrastructure. Of course, like again, what's the nice thing about blockchain? If you want to do it yourself and host infrastructure yourself, you can do it. Like it's no problem. You can do everything. Everything is open source. There is this open source mentality, so you can take and do it. But if you want to focus on the business parts of your projects in particular, and not on the infrastructure parts, then using something like Presto is very good. And apart from this, it also has some extra services that's coming from it, like the indexer, like if you want, or some other things that are coming together.
And what's the level of entry? Is it really difficult for somebody to start using this technology right now? Because before it was close to impossible to get and build your own blockchain. Now you can deploy it. And what's the level of complexity there?
It's just more of a product knowledge of than the I mean, you need to know the basics of how to develop on the blockchain. I don't know. Back then it was like something like Consensus Academy courses or something is enough. But yeah.
So you should know at least how to deploy some smart contracts, right?
Yeah, if you know how to deploy smart contracts on Ethereum or something else, that should be easy.
This has been great. I thoroughly enjoyed our chat. Let's do more of those. And any closing words? Anything you want to say, to highlight?
Well, that's the most difficult question always. No, but I think like I know that right now we are in the market when it's like a little bit less hype about the blockchain. And I think that's a good thing, because it kind of filters out a lot of the speculation on this and leaves more like technology to shine instead of just get rich quick schemas and stuff like this. So I think that's a generally good indication, and we see that blockchain is becoming more and more coming towards the adoption. But again, it looks like there's going to be like a more silent adoption, because blockchain being more infrastructural thing. You will not be able to chat with it or something. It's just, I mean, your app maybe will not even change a single bit but it just will be like more efficient, more secure and stuff like this. So I don't know if that counts as closing words, then there's that.
Very good indeed. Yeah, I'm so happy to see that the speculation is calming down and the technology is actually coming to light. That's brilliant. It has been an amazing conversation, and again, thanks for coming, and wish you a pleasant day.
Yeah, thanks for having me. Thanks.
For every on-chain project, we've built a smart engine which fits any use case, offers bank-grade ZK security, handling over 100 million daily transactions with 10 times storage savings, 240 times faster sync time, with all the tools necessary included, with only 3 clicks to set up, all while costs fade into the distance. It's Presto by Gateway.